Since 1900, the baseball rule has been in force in the United States. This law prevents a spectator from suing a professional baseball team for injuries suffered by said spectator if struck by a foul ball. And there's always a clearly defined disclaimer on every ticket. It says, "Holder, on behalf of himself, herself, and minor, acknowledges and assumes all risks and dangers associated with holder and/or minor being a spectator before, during, and after a baseball game." An NBC News investigation uncovered at least 808 reports of injuries to fans from baseballs from 2012 through 2019. The injuries include concussions and permanent vision loss. But there were fatalities as well. In 2018, an elderly woman celebrating her 79th birthday at Dodgers Stadium in Los Angeles died after being hit in the head by a foul ball. If a baseball can do that at an average baseball speed, what will happen if its speed increases? In this video, you'll find out, can a baseball break the air? Who's trying to warp the universe? And what will happen if a baseball hits Mars at the speed of light? But first, is it at all possible to get a ball to Mars from the Earth's surface? The speed of a common straight pitch in baseball, the so-called fastball, is 149 kilometers per hour. But there are players with exceptional fastballs. For example, the Cuban missile himself, Aroldis Chapman. He's a Cuban-American professional baseball pitcher. He has the record for the fastest recorded pitch speed, 169 kilometers per hour. At that speed, the ball can go beyond the field, reach a parking lot, and damage someone's expensive car. Unless, of course, nobody catches it. And what if we increase the ball speed to half the speed of light? Let's say Aroldis Chapman breaks his own record and pitches a ball with drastically increased speed. With each moment, its speed will increase until it reaches just a little over 500 million kilometers per hour. The ball will go right up into the Earth's atmosphere. This is something the baseball world has never seen before, and more's the pity. In the atmosphere, the air molecules are basically stationary relative to the ball. They're more likely to constitute something like a vibrating mass. The ball will hit that mass at a speed of 135,000 kilometers per second, although air normally moves around everything that travels through it. In this case, it just won't have time to do so. The air will become akin to a solid substance standing in the ball's way. When the ball collides with the air molecules, gamma radiation and particles will be spit out in every direction. These gamma rays and particles will start separating electrons from nuclei, and a hot plasma sphere will form around the ball. And then there will simply be no way of preventing the coming cataclysm. Ball parts will start detaching and destroying air molecules. Something like a chain reaction will occur, with each particle triggering more and more plasma cycles. And eventually, in several dozen nanoseconds, there will be a thermonuclear explosion. The kinetic energy of the ball will reach 450 kilotons of TNT equivalent. That's like 25 Hiroshima bombs. Back where the pitch started, there'll be nothing left of Aroldis Chapman, or for that matter his team, the opposing team, or any of the spectators, or even the stadium. In fact, the place where he threw the ball will be replaced with a crater a few kilometers in diameter, and the ball didn't even make it off the Earth, let alone get to Mars. But I hear you asking, what will happen if you throw the ball from space? There's always something hitting Mars. Rocks, debris, meteorites. Most of the particles are 5/100ths of a millimeter in size. But some leave enormous craters. This is how the Hellas Planitia, 2,100 kilometers across, appeared on the surface of Mars. The same goes with Utopia Basin, at 3,300 kilometers across. A baseball weighs 149 grams and is no more than 8 centimeters in diameter. Something tells me it's not going to leave such a crater, unless we try increasing its speed to the speed of light. The light quantum, the photon, gets to Mars from the Earth in 3 minutes and 2 seconds. However, that exact timing is only possible twice a year when the planets are at a minimum distance from each other. At other times, it can take up to 28 minutes and 12 seconds. A photon's speed is about 300,000 kilometers per second, but only massless particles can reach that velocity. A baseball has mass, so we're going to accelerate it to 270,000 kilometers per second. That's 90% the speed of light. Even the fastest meteorites travel at a speed of only 42 kilometers per second, which is 0.01% of the speed of light. Anyway, when moving at such a speed, the ball's mass would increase proportionately and exponentially, finally becoming infinite at the speed of light, if such a thing were possible. At the speed of light, you'd need infinite energy to move or hit the ball. Say, maybe the Infinity Gauntlet could do the trick. The ball's infinite mass will also make its gravity infinite. Mars would be annihilated if hit by the ball. The ball itself would turn into a super powerful black hole, consuming all the remnants of the planet, and then some. But even if a black hole doesn't form, Mars can't avoid its impending doom. In fact, even a typical comet with a diameter of just half a kilometer would be enough to initiate an end-of-the-world scenario, that world being Mars. Elon Musk would cry again. It turns out, the size of the ball doesn't matter. The shape doesn't matter either. It's all about speed. So, you may be wondering what would happen if we launched an entire ball-shaped spaceship to Mars, but this time shaped like a football. Okay, maybe you weren't wondering that, but be that as it may, we're talking about a real development here. And when we say football, we mean an American football, not one of those funny-looking round Euro balls. The plan is being carried out by a man named Harold White together with his team. White is the leader of a small research group at the Lyndon B. Johnson Space Center, that is, from NASA. The project participants are planning to construct this football-shaped spacecraft. And the most exciting thing is they say they're going to accelerate the ship to a speed exceeding the speed of light. They believe they can succeed if they find a way to bend space and time. In theory, it is possible. For example, zipping through a hole in the fabric of space-time that connects two distant parts of the universe. Or use so-called warped space, like in Star Trek. This phenomenon resembles moving walkways at airports. You can walk on them without exceeding your own personal speed limit. However, you get from one end of the terminal to the other much faster than if you had walked without the moving walkway. But in any case, a warp drive is necessary to achieve such a speed. The fictional propulsion system favored in so many of our beloved works of science fiction is theoretically doable. White's team plans on putting this idea into practice for realsies. The drive is designed to redistribute dark energy in space around the spacecraft, moving the ship forward. The Alcubierre warp drive is what they call it, the bubble enclosing the football-esque spacecraft. Miguel Alcubierre first presented the idea back in 1994. If White succeeds, travel time to Mars will be reduced to a mere 3 minutes. But what, you might ask, would happen if the speed gets too fast and things get out of hand? The ship will presumably crash right into Mars and cause a supermassive mega uber-duper space explosion. Mars will be blown to bits, and we'll have meteor showers of debris here on Earth for quite a while. Most of the Martian detritus will burn up in the Earth's atmosphere, but not all of it. Some of the bigger fragments could make it through the atmosphere, and then humanity would perish. Alternatively, after the explosion, an interplanetary dust cloud will form. As a result, sunlight reaching the Earth will be diminished, the temperature will drop, and all life on Earth will be radically altered, if not extinguished. Green plants form the basis of the food chain on our planet, and they need solar energy. With much less sunlight, they're going to become scarce or even die out. This will lead to unpredictable consequences, but I still want to believe that baseball will stay with us. It'll just be different. I think the field will be covered in ice instead of sand and grass, and the players, of course, will have to wear ice skates instead of shoes. Please write to us in the comments. What do you think post-apocalyptic baseball will look like?